A blue planet hangs in darkness, fragile in its balance. Its oceans neither boil away nor freeze solid. The distance from its star is narrow, a thread of stability, where rivers can flow and air can shelter breath. The moon holds its tilt steady, a silent partner making seasons bearable. Farther out, Jupiter bends its vast weight to intercept comets that might have shattered everything. Too many dials are aligned, too many conditions converge. Why does so much precision exist in a universe born from chaos? The paradox is unavoidable. If perfection ruled, the cosmos would be sterile. Uniform matter would never clump. Stars would never ignite. Galaxies would never spiral outward. But because there were flaws, uneven patches of density, the void became textured. Those imperfections are not accidents. They are the engine that turned silence into light. Why would a universe that appears fine-tuned for survival also weave disorder into every seam? Is it the flaws that truly allow life to arise? Think of a control room lined with glowing panels. Each knob sets the strength of a force. Each switch determines whether elements will bind or break apart. The values are impossibly exact. A fraction stronger for gravity and stars would collapse too quickly. A fraction weaker and no atoms would ever settle into stable form. This uncanny tuning, often noted by physicists, feels deliberate. Yet the same dials leak small irregularities, and those irregularities create the very web of structure. How can precision and accident be so deeply entangled? In plain terms, the universe had to be both stable and unstable. Stability let atoms endure, but instability seeded galaxies. A perfectly uniform cosmos would be as silent as a blank sheet of paper, but add tiny wrinkles, and suddenly words appear. Without turbulence, no stars. Without stars, no carbon. Without carbon, no us. Could it be that the defects are not errors, but requirements? Could it be that imperfection is the hidden foundation of every breath we take? A long time ago, light decoupled from matter. It spread in every direction, leaving behind a faint glow we still measure. That glow is not smooth. It is freckled with temperature differences, 1 part in 100,000. To human eyes, they are invisible, but to instruments, they are clear. These minute flaws became the skeleton of cosmic structure. Clusters, filaments, voids, all grew from those primordial imbalances. What would the universe look like if such freckles had never existed? Would there even be a sky to contemplate? Simply put, order alone would freeze the universe in stillness. Flaw alone would dissolve it into chaos. But together they created a space where time could stretch and change could occur. The very forces that seem perfectly tuned also produce turbulence. What does that mean about the nature of design? Or about chance itself? If the dial is fixed and the crack is essential, then survival may not be a miracle, but the natural outcome of tension between two opposites. Imagine pouring water into a bowl. If the bowl is perfectly smooth, the water sits flat and lifeless. Add a tiny bump, and ripples spread outward, giving motion and pattern. Our cosmos is that bowl, with bumps scattered by quantum uncertainty and stretched across space. Those bumps guided matter into shapes. Without them, the bowl would remain still and barren. Why should randomness be the mother of architecture? Why is noise the parent of harmony? To put it another way, the perfection we see is never pure. It is always laced with deviation. The habitable zone is not a fixed band, but a range maintained by competing forces. The moon's steady hand is imperfect, its distance slowly shifting, its pull altering tides across ages. Jupiter's shield is not absolute. Some comets slip through, and life endures through extinctions as well as through protection. Perfection is never complete, and in those gaps, life finds room. What this means is that existence is not built upon flawless law, but upon law that tolerates fracture. Every galaxy is a record of both obedience and rebellion. The rules of physics dictate behavior. but fluctuations make stories. Without the break, there is no melody. Without the crack, there is no vessel to hold light. If we call the universe tuned, we must also call it cracked. If we call it precise, we must also call it flawed. Is that contradiction, or is it the only way life can happen? In everyday language, we are children of a broken clock that still keeps time. The tick is steady enough to count days, yet every imperfection creates seasons, climates, and paths of history. A machine set without tolerance breaks at the first pressure. A cosmos without tolerance would break before it began. Perhaps what appears as tuning is really resilience. Perhaps the flaws are not mistakes, but allowances. Why else would the universe be written in both rigid numbers and wandering chance? At its core, the puzzle is this: a universe with neither precision nor error cannot host life. Precision alone is sterile. Error alone is destructive. Only together do they create balance, tension, and growth. The paradox is not a flaw of explanation, but the essence of reality. Every scar is part of the story. Every tilt is part of the dance. Every instability is part of the symphony. Why should our existence depend so deeply on the marriage of opposites? What larger truth lies hidden in this embrace? Think of it like this. We are standing in a hall of mirrors, but every mirror is cracked. The cracks distort. But without them, we would see only endless repetition. The distortions make the reflections meaningful. Our cosmos is such a hall. It is both orderly and shattered, and in the fractures we find identity. Without those fractures, no observer would stand here to ask questions. Are we therefore proof that imperfection is necessary, or are we only witnesses to one path among many? We return to the night sky. Stars burn because nuclear forces are finely balanced, yet they cluster because density was uneven. Planets form because disks are unstable. Life evolves because environments shift. At every scale, perfection alone would suffocate, and chaos alone would annihilate. It is their uneasy partnership that carved rivers, built continents, and filled skies with light. The truth is unsettling. We rely on flaw as much as on law. Why then do we still seek perfection when survival clearly depends on imperfection? Stay with the quiet universe. A pale light spills across a narrow band circling a star, and within that thin ring of warmth, Earth drifts like a watchman in a tower. The band is small, fragile, and mercilessly precise. A little closer, and oceans would vanish into steam. A little farther, and they would freeze beneath a crust of endless ice. This is the first clue, the setting that determines whether chemistry blossoms or falls silent. We live not in a broad, safe expanse, but in a knife-edge corridor, guarded on all sides by silence. The Watchtower metaphor matters because it suggests vigilance. A watchtower surveys danger, scanning for threats in every direction. The habitable zone is such a tower. Its walls are fragile atmospheres. Its vantage point is the balance between radiation and shadow. Why does life demand such narrow tolerances? Why should existence be possible only within margins so tight? This contradiction lies at the heart of cosmic design. From one angle, it feels impossibly deliberate. From another, it feels like a prison of chance. We must see clearly before we interpret. Earth receives about the right amount of energy to sustain liquid water, but only because atmospheric chemistry modulates the raw heat. Clouds reflect. Greenhouse gases trap. Albedo shifts with ice. The zone is not rigid. It breathes with geology and sky. To understand the meaning of this, researchers often compare models across stars, noting how subtle differences in luminosity shift the boundaries. A world orbiting a cooler star might need to hug closer. One circling a hotter star must drift farther. The significance is immense, because habitability is not fixed. It is conditional, contingent, always on the verge of collapse. Simply put, life as we know it requires a balance that is both generous and fragile. The sun burns with stable hydrogen fusion, but only for a few billion years. The tower we live in has a timer. Eventually, the safe band moves outward, leaving Earth behind. What matters is that we are alive during the interval when the tower's light falls exactly right. That timing hints at deeper questions. Why are we here now? Why not earlier? Or later, when conditions would differ? Consider the moon's influence. It stabilizes Earth's tilt, limiting climate swings that might otherwise destabilize long evolutionary arcs. Without this partner, ice ages could be harsher, tropics more extreme, and ecosystems less stable. The moon is not perfect. Its distance shifts slowly outward, altering tides over time. Yet the very imperfection creates dynamic coastal zones where life thrives. Scientists note that tidal pools might have been laboratories of chemistry. Again, we see flaw working with precision. A tilt too wild ends the experiment. A tilt too rigid freezes progress. Instead, we have a rhythm that both challenges and sustains. In plain terms, the Watchtower does not stand alone. It is buttressed by companions. Jupiter, massive and restless, patrols the outer darkness. Its gravity deflects or swallows many incoming bodies. Yet it also perturbs orbits, sending comets inward, a shield and a threat, a sentinel and a gambler. Extinction-level events remind us of this dual role. Paleontological layers tell the story of impacts both survived and catastrophic. Does this balance of risk and protection explain our survival? Or was survival itself an accident that only looks inevitable in hindsight? A rhetorical question rises here. What if the tower collapsed? What if Earth's orbit shifted even slightly? Would life adapt? Or would it vanish without record? Some argue adaptation is robust, pointing to extremophiles that endure in acid or ice. Others insist thresholds are real, that liquid water and stable climates are non-negotiable. The contradiction forces us to recognize limits. We are not merely children of resilience, we are children of circumstance. Which one carries the greater weight? To put it another way, the habitable zone is a story of margins. It is not destiny. It is a temporary grant. Stars brighten with age. Orbits can drift. Planetary atmospheres can transform. Venus likely once held oceans. Now it smolders beneath a crushing blanket of carbon dioxide. Mars may have been wetter. Now it lies cold and barren. The tower overlooks many ruins. Why did Earth endure? Why did Earth's chemistry hold the line? Perhaps luck, perhaps a deeper law, perhaps both. Evidence from comparative planetology supports this view, with researchers noting the fragile balances of greenhouse effects, orbital eccentricity, and planetary mass. From these studies emerges a pattern: habitability is rare, transient, conditional. Yet we are here, and that presence must be accounted for. This is the breakthrough of perspective. The Watchtower is not a fortress with walls. It is a narrow balcony open to winds, crumbling at the edges. The meaning is not that we are protected forever, but that we exist in a fleeting window, one that invites questions about timing, about coincidence, about the hidden architecture of possibility. What this means is that our sense of permanence is illusory. Civilizations rise and record their confidence in eternity. Yet the tower is already shifting beneath them. Climates warm, seas move, continents drift. On cosmic timescales, the safe corridor is ephemeral, but in that ephemerality lies meaning. Life does not require infinite time. It requires only enough time to think, to adapt, to ask. Perhaps the narrowness of the zone is not a cruelty, but a filter, one that selects for minds that know they are fragile. Another rhetorical question follows. Why do we expect stability when instability is the engine of creativity? If Earth's orbit were unchanging, if climates never shifted, would evolution ever accelerate? Would intelligence emerge in a world with no pressure to adapt? A competing view holds that too much pressure would crush, too little would stagnate. Only the edge creates momentum. Only the watchtower's narrow view creates vigilance. Does this mean life itself is sharpened by the knife edge? That awareness is born in danger? In everyday language, you are alive because the sun shines at just the right distance and the planet leans at just the right angle. But you are also alive because that arrangement is unstable enough to force adaptation. Coastal tides, seasonal changes, climatic fluctuations, all are products of imperfection. If the watchtower were flawless, its view would never change. And in that unchanging view, perhaps nothing would ever wake to notice. Why it matters is simple habitability defines possibility. Without the watchtower, there is no chemistry complex enough to evolve. Without its fragility, there is no drive to transform. The habitable zone is not a comfort. It is a challenge. It dares life to adapt before the corridor vanishes. It frames existence not as a gift of eternity, but as an invitation to urgency. To live is to know the tower will not stand forever. And yet, the story does not end here. The watchtower looks outward, scanning seas of darkness. But what lies in that darkness holds the next clue. For beyond the safe corridor of warmth, the universe keeps another map, a map written in light. The universe carries its oldest memory not in stone, not in dust, but in light. It is a map spread across the sky, faint and nearly uniform, a background glow that seems at first glance unremarkable. Yet when examined with careful instruments, that glow is freckled with tiny differences. Temperature shifts of only a few parts in 100,000. To the naked eye, the sky looks smooth, but to a radio telescope, it is patterned with scars. This is the forgotten map of light, a relic from when the universe was only a few 100,000 years old. Why should something so faint hold the keys to everything we know? The clue is simple. These faint ripples mark the first imbalances. Matter, once evenly distributed, carried slight variations in density. Without them, nothing would have condensed. No galaxies, no stars, no planets, no you. The paradox is stark. Uniformity appears stable, but stability would have killed creation. Disorder appears fragile, yet fragility birthed resilience. Observers sometimes describe the cosmic microwave background as a snapshot of the baby universe, frozen when matter and light parted ways. In that frozen moment, imperfection was preserved as destiny. We must understand what this means. Light once bounced freely among particles, scattering so often that the cosmos was opaque. As the universe cooled, electrons bound to nuclei, creating neutral atoms. Photons at last traveled unhindered, carrying with them the record of those tiny density shifts. Instruments like satellite observatories mapped this faint afterglow with exquisite accuracy, revealing not random noise, but structured patterns. Peaks and troughs etched across the sky correspond to sound waves rippling through primordial plasma. The universe was humming long before stars began to shine. Why did those ripples matter? Why should ancient sound waves still shape the galaxies we see? Simply put, the forgotten map is not just a picture. It is a blueprint. It encodes the seeds of all large-scale structure. Astronomers studying the power spectrum of those ripples can predict the sizes of clusters and voids billions of years later. That predictive success is astonishing. From a baby picture blurred by time, we can reconstruct the architecture of everything. This predictive reach convinces many researchers that these patterns are not accidents, but evidence of deep laws. What kind of laws demand such precision, and yet preserve such irregularity? Consider the contradiction. If quantum fluctuations were too small, matter would have spread evenly forever, never clumping, never igniting. If they were too large, chaos would reign. Black holes would dominate, and stable worlds would be rare. Instead, the scale is balanced between futility and excess. A middle path carved by probabilities became a path to life. Some teams suggest this balance is evidence of inflation, a sudden expansion that stretched microscopic variations to cosmic size. Others propose that alternative mechanisms might achieve the same. The debate remains open, but the implications are vast. What does it mean that chance, stretched to infinity, becomes the foundation of necessity? In everyday language, picture cracks in drying paint. They seem random, but they guide the way the surface will fracture, shaping every later feature. The universe's first cracks were those tiny fluctuations. They may have looked insignificant, yet they set the stage for everything. You can read a city's age in its peeling walls. You can read the cosmos' origin in the freckles of ancient light. Why would such fragile traces matter so much? Why do we find design written in blemishes? The breakthrough lies in recognizing that imperfection is not an afterthought. It is the generator. Observers studying the background light find that the spectrum of fluctuations matches predictions from physics that also explain nuclear abundances and galaxy clustering. The agreement is too close to ignore. Some see in this a triumph of theory, others a hint that we are only glimpsing part of a deeper pattern. The chase continues, because every refinement of the map sharpens questions as much as answers. If inflation happened, what field drove it? If fluctuations were quantum, why these scales? Why this amplitude? Why here? Why it matters is clear without the forgotten map of light. The universe would be mute. There would be no scaffolding to catch matter, no wells to form stars, no galaxies to hold planets. Life depends on wrinkles in the fabric of reality. The precision of measurements, as noted by multiple research groups, affirms this dependency. Yet the paradox returns. If imperfection is the root of structure, does perfection mean silence? If noise is essential, should we stop calling it noise at all? To put it another way, the light across the sky is a diary written before any eyes could read it. Its entries are uneven, smudged, incomplete. But without those smudges, the diary would be blank. The forgotten map is not beautiful in the classical sense. It is messy, but in that mess is meaning. The universe records itself by flaw, and the flaws sing. Why should such music endure for billions of years? Why should it carry through voids unbroken? Another rhetorical question rises. If imperfections are so necessary, could other universes exist where the scales tipped differently? Some theories say yes, envisioning countless maps, some too smooth, some too violent, only a few carrying the right mixture for complexity. If that is so, then we exist precisely because our map is neither forgotten nor irrelevant, but uniquely tuned. Yet this explanation invites unease. Is survival just luck, or is there some deeper principle that makes our map inevitable? In plain terms, the cosmic background is a photograph of imperfection, preserved in radiation. It is not decoration, it is foundation. Every glance upward is a chance to read that foundation again. Every pixel of the sky is a record of beginnings. If we forget this map, we forget our own story. The forgotten map reminds us that nothingness alone cannot give rise to life. It takes fluctuation, imbalance, and chance. And in those qualities, fragility becomes strength. The bridge leads onward. If a map of ancient light could shape galaxies, then what unseen scaffolding cradled those first sparks of matter? There is a weight pressing through the cosmos that no eye can see. It bends starlight. It tugs on galaxies. It sculpts clusters into sprawling webs, yet it remains invisible. This is the sleeping giant of shadow, the hidden mass we call dark matter. Its presence is not announced by light, but by influence, a silent grip that holds the luminous universe in its hand. Why would creation rely so completely on something that refuses to reveal itself? The clue lies in motion. When astronomers tracked stars orbiting within galaxies, they expected speeds to taper off at the edges, just as planets in the solar system move slower when farther from the sun. Instead, outer stars raced with nearly the same velocity as inner ones. Something more than visible matter must have been exerting gravity. The contradiction was unmistakable. The luminous matter was too little, yet the pull was too great. The maps of gravitational lensing, where distant galaxies are distorted by intervening mass, reinforced this finding. We saw through bending what we could not see by shining. The sleeping giant was confirmed, though its identity stayed hidden. To put it another way, the cosmos is like a stage whose beams are obscured behind curtains. Actors perform beneath, oblivious to the scaffolding that carries the roof. Dark matter is such scaffolding, unseen yet essential. Without it, the fragile ripples recorded in the background light would not have grown into galaxies. Gas clouds would have dispersed before igniting into stars. The blueprint of structure required both the freckles of radiation and the shadowy giant to amplify them. Why should the largest contributor to cosmic form be the most elusive to human eyes? Simply put, dark matter clumps together, creating wells that ordinary matter falls into. Evidence from multiple surveys shows how filaments of invisible mass connect galaxies into a web, a cosmic net that binds the luminous islands together. The meaning is profound. We live not in an empire of stars, but in an empire of shadows, with light decorating only the surfaces. If this hidden substance were absent, would the universe be barren, stillborn, a mist that never congealed? Another rhetorical question emerges. What exactly is this giant? Some propose new particles, perhaps weakly interacting, perhaps massive, but shy, passing through matter like ghosts. Others imagine actions, feather-light quanta filling space as waves. Competing views hold that gravity itself may require revision, that the law we think we know bends differently at galactic scales. The uncertainty is deep. Why would the foundation of existence resist detection so completely? What is it that the cosmos still refuses to tell us? In plain terms, we know dark matter is there because galaxies behave as though they are held in a grip too strong for visible stars to supply. The grip is real, measurable, confirmed by observation after observation. Yet the hand that grips remains invisible. This paradox unsettles. Science usually explains the seen by reference to the seen. Here, the seen is explained by the unseen. How much of reality do we miss simply because we demand light? The breakthrough in our understanding is this: without shadow, light has no stage. Without the giant, galaxies would not survive their own spin. The chase for its nature continues with underground detectors buried deep to avoid stray radiation, with satellites scanning for faint signals, with colliders seeking exotic particles. Each attempt sharpens the boundary of possibility, yet the quarry remains out of reach. It is as if the giant sleeps deliberately, its presence undeniable but its name withheld. Why does existence hide its pillars in silence? Why it matters is urgent. Dark matter accounts for nearly a quarter of the universe, far outweighing the matter we are made from. If we do not know its nature, we do not know the universe. Without understanding it, cosmology is half-blind, physics is unfinished, and our place is less clear. This is not a small omission. It is a wound in knowledge. To build our story on light alone is to ignore the foundation beneath. How can meaning be complete when the scaffolding is invisible? In everyday language, you live in a house supported by beams you have never seen. You trust the roof because it has not fallen, but you cannot describe the wood. That trust is practical, but it is not knowledge. Similarly, we trust dark matter because the universe holds together, but trust without understanding is only provisional. What if those beams are stranger than wood? What if they are not beams at all, but some deeper architecture? Another rhetorical question surfaces. If shadow builds the first rooms of the cosmos, then what role does it play in our existence now? Does it shape the distribution of habitable galaxies, the timing of star birth, the longevity of worlds? If so, then even our consciousness is indirectly a child of shadow. To deny the giant is to deny our own ancestry. Is awareness then not only made of atoms, but also sculpted by what atoms cannot reveal? What this means is unsettling. We chase particles that may never appear, theories that may never collapse into certainty, yet the absence of clarity does not erase significance. The sleeping giant shows that ignorance itself can be fertile. By not knowing, we are forced to question more deeply, to stretch imagination further. The darkness is not emptiness, it is invitation. Why else would the cosmos hide its greatest mass in plain invisibility? The bridge is waiting. If unseen scaffolding built the first rooms, then what quiet address sheltered us within the vast and violent galaxy? The Milky Way is no gentle neighborhood. Its central bulge swarms with stars packed close enough to collide. Its spiral arms churn with supernovae that flood space with lethal radiation. And black holes wait in ambush at the heart of clusters. Yet here we are, orbiting the edge of one arm, in a suburb that seems unusually calm. Our home is not in the crowded center, not in the emptiness of the far outskirts, but in a middle ground where violence is distant and quiet endures. Why did life emerge at this particular address in such a dangerous city of stars? The clue is location. Earth circles the Sun about 25,000 light-years from the galactic center, a place astronomers call the galactic habitable zone. It is not a ring of safety guaranteed by law, but a band where conditions happen to converge, too close to the core, and tidal forces and high-energy radiation disrupt planetary systems, too far out, and heavy elements needed for complex chemistry grow scarce. Our address sits between these extremes. The contradiction is striking survival demands both enrichment and isolation, a paradox of proximity and distance. What does it mean that we live in this fragile equilibrium? In everyday language, imagine choosing an apartment in a massive city. The center is alive with light and noise, but unsafe. The outskirts are quiet, but lack resources. The safest bet is often a suburb, enough access to materials, enough distance from chaos. Earth's location is such a suburb. We are close enough to have metals forged in earlier generations of stars, but far enough to avoid constant bombardment by the galaxy's more destructive events. How could such a balance have arisen without chance? Or is chance the wrong word? Simply put, the evidence suggests our address matters. Studies of exoplanets show that stars too poor in heavy elements seldom host rocky planets. Yet stars too enriched may lie in dense regions where nearby explosions sterilize worlds. Our Sun sits in a band of intermediate metallicity, enriched enough to build Earth but not so dense as to endanger it constantly. This balance has been noted by astronomers comparing hundreds of stars, who find habitable candidates are not evenly spread but cluster in certain zones. Why then are we in one of those zones? What principle guided this arrangement, if any? Another rhetorical question rises: are quiet suburbs rare or inevitable in a galaxy so vast? If rare, then our existence feels improbable. If inevitable, then countless other worlds may enjoy similar safety. Both answers challenge us. Improbability invites wonder about hidden design or multiversal lotteries. Inevitability suggests we may not be unique at all. Which explanation better fits the evidence, and what would each mean for our sense of place? The breakthrough is realizing that safety is never absolute. Even our quiet address is scarred by past disasters. Craters on Earth testify to impacts, while records of mass extinctions remind us of vulnerability. The difference is frequency. The galaxy's violent events occur everywhere, but in some regions they occur less often. Enough time is bought for complexity to grow, for resilience to evolve. Life is not guaranteed, but it is given chances. Why it matters is clear without the buffer of relative calm. Evolution's long arcs would be broken too often to sustain intelligence. In plain terms, our solar system lives on borrowed safety. The suburbs are not eternal refuges, only quieter streets. Catastrophe can still arrive, but with intervals long enough for recovery. Dinosaurs fell to such an interval, but mammals rose in the same pause. The cycle continues. What does it mean to live knowing that disaster is inevitable but not immediate? Does awareness itself depend on knowing that time is both granted and finite? Another rhetorical question presses us: if the galaxy is so violent, does every conscious species rise under a shadow of fragility? Are civilizations across the stars shaped by the same awareness of impermanence, the same urgency? If so, perhaps quiet addresses breed not only survival, but reflection. Perhaps intelligence requires the paradox of calm surrounded by chaos. Could that explain why minds arise in suburbs and not in centers? Evidence supports this framing, with researchers mapping gamma-ray bursts and noting that their frequency is lower in regions like ours. They conclude that habitable epochs are most likely in places where radiation rates are lower, but metallicity remains sufficient. This is not absolute proof, but it strengthens the notion that location is critical. What this means is that life is not scattered randomly. It emerges in patterned shelters, carved by the violence it must escape. Our survival is not against the galaxy, but within it, using its structure as shield. At its core, this chapter of our story is about limits. We are not at the center of the galaxy, as once imagined, nor at its margins. We are balanced between, and that balance is fragile. The violent city is all around, but our street is quieter. What should we infer from that quiet? Should we see providence, or probability, or coincidence? The galaxy does not answer. It only shows us scars and silences, and from them we draw our conclusions. Why it matters is that our sense of security is contingent. To imagine the cosmos as welcoming is a mistake. To imagine it as purely hostile is also a mistake. The truth is between. The city is dangerous, but not uniformly so. The suburbs grant time, and time grants thought. This fragile gift is enough to wonder, enough to build telescopes, enough to tell stories. The violent galaxy still rages, but we endure because we are slightly off-center, slightly lucky, slightly sheltered. And so the bridge opens. If a quiet address can shape survival, then perhaps our very awareness is also shaped by how we think about observation itself, leading us into the labyrinth of anthropic reasoning. We have followed the watchtower of distance, the map of light, the shadow of scaffolding, and the shelter of our galactic suburb. Each clue has shown that survival depends on improbable balances. Yet there is a deeper puzzle that emerges whenever we ask why those balances exist at all. This puzzle is the labyrinth of anthropic thinking, a hall of mirrors where every answer seems to fold back into the questioner. Why does the universe look so precisely arranged for life? And do we see it that way only because we are here to ask? The clue begins with observation itself. Constants like the strength of gravity, the charge of the electron, and the ratio of forces are measured with precision. They seem arbitrary, yet they fall into ranges that allow chemistry, stars, and time. If gravity were slightly stronger, stars might burn too quickly. If weaker, they might never ignite. These numbers could be anything, yet they are not. The contradiction is sharp, they seem finely tuned, but we have no explanation for why they must be this way. Are we misled by our own presence, mistaking inevitability for necessity? In everyday language, it is like walking into a house and finding every window set just to let in the right amount of light. Do we marvel at the design? Or do we realize that only in such a house could we sit comfortably enough to notice? The anthropic principle, in its weak form, says that we should not be surprised to find ourselves in a universe suited for us, because universes unsuited for life would never have observers. This logic feels circular, but it carries weight. Without it, we risk ignoring the filter imposed by our own existence. Still, the circle raises more questions than it resolves. Is this reasoning explanation? Or is it merely survival bias dressed as insight? Simply put, the labyrinth begins when we step into this hall of mirrors. Each reflection shows us ourselves, but shifted, distorted. Some thinkers argue that the anthropic perspective is trivial, almost tautological. Others argue it is profound, hinting that observation itself is part of the architecture of reality. The contradiction is inescapable. Are we just lucky ticket holders in a cosmic lottery? Or does the lottery itself demand explanation? If so, what mechanism selects the winning numbers? One rhetorical question rises sharply if there are countless possible universes, most sterile. Why are we in one of the rare fertile ones? The weak anthropic principle shrugs and says, because you could not be elsewhere. The strong anthropic principle ventures further, suggesting that perhaps the universe must be such as to allow observers. But must it? What forces would demand such necessity? And is necessity the right word, or merely an illusion born from our singular vantage point? The breakthrough in this maze is recognizing that our existence is both filter and data point. We cannot ignore that the constants allow life. But we must also admit that we cannot easily separate explanation from condition. Evidence from cosmological modeling shows how sensitive structure is to initial parameters. Small changes cascade into universes either too simple or too chaotic to bear life. Yet the presence of such sensitivity does not explain why the numbers land within the narrow band. The labyrinth deepens, its corridors winding between coincidence and principle. What this means is unsettling. If we invoke chance alone, the improbability strains comprehension. If we invoke necessity, we risk presuming purpose where there may be none. Some propose multiverse scenarios, in which countless universes exist with varying parameters. In such an ensemble, our existence becomes less surprising, a natural outcome of vast statistics. But this answer drags us deeper into speculation, for we cannot observe beyond our horizon. How can we test what we cannot see? Are we still within science, or stepping into metaphysics? Another rhetorical question emerges. If the multiverse explains fine-tuning, does it also rob our universe of uniqueness? Does it turn significance into inevitability? Or does it expand meaning, showing that life can bloom in more than one way? Which vision honors the evidence, and which projects our hopes? The labyrinth offers no easy exit. Each door opens to another hallway. Each answer turns into another question. The chase itself becomes the revelation. In plain terms, anthropic thinking forces us to recognize the role of perspective. We see a universe that allows us, but we cannot decide whether that is accident or law. Our knowledge is filtered, and the filter shapes the story. That recognition is both humbling and frustrating. It denies us the comfort of finality, but it grants us the clarity of limits. We are not omniscient observers. We are embedded participants, and our very existence conditions what we can know. Why it matters is clear. The labyrinth teaches caution. Without it, we might mistake improbability for miracle, or probability for inevitability. With it, we acknowledge that our survival colors every question we ask, that humility is essential if we are to navigate cosmic mystery. It reminds us that explanation is not only about equations, but also about vantage point. We must account for our own reflection in the mirror of the universe. Another rhetorical question lingers at the exit. If anthropic reasoning is a hall of mirrors, does it trap us or free us? Does it paralyze inquiry or sharpen it? Perhaps both. Perhaps the maze is not meant to end, but to force us to think differently, to seek hidden corridors. What larger horizon might appear if we accept that the mirror is part of the structure? The bridge awaits. If the labyrinth shows us our reflection, then the next chamber holds an even stranger possibility, that the shelves of unseen rules, the hidden dimensions of reality itself, may contain the answers we seek in the shadow library. Beneath the structures we see, beneath the balances we measure, there may exist shelves of hidden laws. This is the shadow library, a vault of possibilities where the constants of nature might be different. The dimensions of space might twist in ways unseen, and the architecture of reality could branch into countless alternatives. The thought itself is intoxicating and troubling. If the universe is tuned, what shelves stocked the dials? And who, if anyone, arranged them? Or does the library exist without librarian? A vast collection where only some books can be opened. The clue emerges from theory. When physicists explored unification of forces, they found solutions that multiply. not simplify. The mathematics of string theory, for instance, suggests a landscape with immense numbers of possible vacuum states. Each state would correspond to different constants, different particle families, different physical laws. The contradiction is sharp the more we search for underlying simplicity, the more diversity we uncover. Instead of one deep reason, we may face a library so vast that our cosmos is but one volume. Why should reality be written in so many languages? And why are we fluent in only this one? In everyday language, think of a software program with hidden settings. Change the brightness, the resolution, or the format, and the same computer behaves differently. The laws we measure could be such settings, defaults chosen by conditions beyond our reach. Are we reading one configuration out of millions? If so, then life exists not because the settings are inherently right, but because we booted up in one version where the defaults happen to sustain chemistry. Does that diminish meaning or expand it by suggesting endless variety? Simply put, the Shadow Library offers two contrasting visions. One is of design, where the shelves are arranged deliberately, each volume placed with intention. The other is of blind multiplicity, where every possible volume exists, and observers appear only in the ones with coherent stories. Both visions are unsettling. The first implies purpose beyond measure. The second implies insignificance within infinity. Which is more acceptable, and which is more terrifying? Do we seek comfort in purpose, or courage in chance? Evidence is suggestive but not conclusive. Some teams argue that the small but non-zero value of the cosmological constant is easier to explain if many universes exist with varying constants. In a vast ensemble, only those with values close to ours would permit galaxies, and therefore observers. Competing views hold that this is philosophy disguised as physics, since other universes cannot be directly observed. Still, the Shadow Library has become a powerful metaphor. The shelves may be out of reach, but the thought of them shapes how we interpret fine-tuning. Are we living in the only book, or in one of countless texts? Another rhetorical question rises. If our constants are defaults, who or what set them? Was it chance, necessity, or selection from possibilities? And if they can vary, what principle governs their distribution? The labyrinth of anthropic thought already taught us caution, but the Shadow Library tempts us with abundance. It whispers that answers may not be singular. They may be plural, overflowing, scattered across shelves we cannot read. How do we live knowing that what we call law may be only local chapter headings in a larger text? At its core, the idea of a library speaks to memory and potential. A library holds not only what has been written, but what could be written. If the cosmos contains such potential, then our universe is a story among many. Why it matters is clear. It reframes uniqueness. Instead of being the only, we may be one of countless variations. That does not erase meaning. It shifts meaning from exclusivity to participation. To exist at all is to be part of a larger chorus, even if we can hear only our own voice. To put it another way, imagine standing in a library where all but one shelf is hidden in shadow. You hold a single book in your hands, and its pages describe everything you know. But faintly, you sense the weight of countless other volumes behind the curtain. That weight is the possibility of other realities. Whether or not you ever read them, their presence changes how you view your own story. Are you content to know one narrative, or restless because you cannot know the rest? Another rhetorical question presses closer. If extra dimensions or hidden symmetries select constants, does that count as explanation or simply a shift of mystery to deeper levels? We may trade one puzzle for another, like descending through trapdoors that never end. Is there ever a final floor in this library? Or is the descent infinite? If infinite, perhaps explanation is not a destination but a path, a pursuit that matters because it stretches imagination. In plain terms, the Shadow Library is a metaphor for possibility. It tells us that reality could be otherwise, that what we measure is not inevitable but contingent. It humbles us, reminding us that our universe is not guaranteed, but conditional, that humility may be the truest wisdom. To live as though ours is the only book is arrogance. To live as though we are one among many is awe. Which posture better suits a species that has only just learned to read the stars? Why it matters is profound. The Shadow Library pushes us to confront scale. Our cosmos may be vast beyond reckoning, but if it is only one volume among countless, then vastness is relative. The shelves extend farther than imagination, and our task is not to master them, but to acknowledge them. That acknowledgement changes how we value our fragile story. It becomes more urgent, more precious, not less, because it is one voice among an unseen choir. Here the reveal demands pause. If the cosmos may be one among many, if our laws are settings rather than absolutes, then the notion of fine-tuning shifts. It is no longer miracle or necessity, but selection from possibility, and that selection need not be deliberate. It can be consequence, a filtering process across shelves we cannot access. This is the moment when speculation collides with identity. If our book is rare, it is wondrous. If it is common, it is comforting. Either way, it changes nothing and everything at once. Join us in the quiet universe. The bridge is set. If the shelves of rules tempt us with abundance, the next step forces us into a darker reflection. What if the mirror of design and selection is cracked, showing two faces at once? Talmutit. A mirror hangs before us, but the glass is cracked. In one fragment, we see the suggestion of purpose, a universe arranged with care, dials set by intention. In another fragment, we see blind processes, natural laws without overseer, chance sculpted by necessity. The image is not whole, and yet both fragments feel true. This is the broken mirror of design and selection, a rift between interpretations that cannot be ignored. Why does existence present itself as if tuned, yet explain itself as if self-born? The clue lies in the oldest arguments. For centuries, thinkers pointed to order as evidence of intention, the regularities of orbits, the elegance of equations, the improbable alignment of conditions. More recently, the precise values of cosmic constants are taken as signatures of tuning. Against this stands a counterweight. Evolution in biology demonstrates how complexity can arise without foresight, through variation and selection. Some propose an analogy at the cosmic scale, suggesting universes might replicate through black holes, their parameters shifting slightly with each generation. This idea, though speculative, reframes fine-tuning as survival of the fittest universes. The contradiction sharpens: do we see purpose because it is there, or because processes mimic its outline? In everyday language, it is like finding a garden in bloom. One explanation says a gardener planted it. Another says seeds scattered, winds shifted, and conditions favored growth. The garden exists either way. Which story do we tell, and which story is true? If universes can reproduce, then selection might sculpt constants just as evolution sculpts traits. But if no such mechanism exists, we are left staring into the fragment that whispers design. Can we live with two faces staring back at us? Simply put, neither fragment resolves easily. The design view raises questions of agency, intention, and evidence. Who set the dials, and by what method? The selection view raises questions of mechanism and testability. How would universes replicate? How would constants shift? Without evidence, both faces remain speculative, yet the mirror will not let us turn away. We are caught between attraction to pattern and loyalty to data. What does it mean that the cosmos resists a single story? One rhetorical question presses close: if the constants look tuned, does that alone prove design? Another asks, if selection can explain tuning, does that eliminate purpose? Both questions reveal the same flaw. Perhaps proof is not possible in either direction. The mirror remains broken, and maybe it must be. Perhaps the cracks themselves are the truth. showing that reality exceeds any one interpretation. Does this mean meaning itself is fractured, or more layered than we dare imagine? Evidence, while thin, provokes thought. Black holes, once seen only as endpoints, are now studied as fertile engines. Some theorists suggest universes might bud from them, carrying altered parameters. Though this remains unverified, the concept highlights a shift-tuning need not imply intention. It might emerge from replication. Competing arguments point out the lack of empirical support, warning against mistaking metaphors for mechanisms. Yet even critics admit the idea challenges the monopoly of design. What this means is that survival itself could be the selector, not foresight. Is this any less profound? At its core, the broken mirror confronts us with ambiguity. To some, ambiguity is weakness. To others, it is depth. Why it matters is not because one face proves correct, but because both faces sharpen awareness of the stakes. If design is true, then existence carries purpose beyond us. If selection is true, then existence carries no intention, yet still achieves order. In both cases, life emerges from frameworks we cannot yet fully fathom. The mirror is cracked, but it still reflects. In plain terms, imagine holding a mirror that shows two images at once. You lean left, one face appears. You lean right, another. Neither disappears, because the crack preserves both. Our understanding of the cosmos is like that mirror. We cannot erase the fracture. We can only decide how to interpret it, and perhaps the fracture itself is the lesson. Complexity resists reduction to one story. Meaning may require holding contradictions, not resolving them. Another rhetorical question haunts us: if both design and selection can explain the same patterns, how do we choose between them? Do we require evidence? Or is evidence insufficient when questions reach this depth? Perhaps choice is premature. Perhaps the cracks must remain until further light shines. Does patience count as an answer, or is it surrender? We are left in the tension. Why it matters is existential. The broken mirror shapes not only cosmology, but philosophy. If design whispers intention, we must ask whose and why. If selection explains order, we must ask what larger framework permits replication. Either way, the mirror returns us to humility. We do not see clearly, we see in fragments. The fracture is not failure but condition. To expect wholeness may itself be illusion. The chapter closes with an image, a mirror reflecting two faces, each incomplete, each true enough to provoke thought. We cannot mend it yet. We can only accept that meaning emerges in cracks as much as in clarity. And as the fragments glow, they direct us toward a deeper horizon, where purpose and process dissolve into questions of existence itself, carrying us into the echo of philosophy. Night falls across the same sky we have studied through dials, maps, shadows, and mirrors. The stars are not only objects of physics, they are symbols of paradox. Each one burns with relentless precision, yet each owes its existence to the irregularities that allowed collapse. The galaxy is violent, yet our address is quiet. The constants look tuned, yet randomness seeds their utility. We arrive at the threshold where science blurs into philosophy, where explanations give way to echoes. The universe is a paradox that both sustains and unsettles. Why then should meaning not also be paradoxical? The clue of imperfection returns. Every chapter has shown that flaws are not accidents, but essentials. Habitable zones are fragile because they shift. Maps of light endure because they are freckled. Galaxies hold together because unseen matter wraps them in silence. Our location in the Milky Way is significant precisely because other neighborhoods are hostile. The labyrinth of anthropic thought tells us our observation itself is a filter. The shadow library hints that reality could be otherwise. The broken mirror reflects both purpose and selection at once. Each motif leads us to the same insight. Perfection cannot exist without imperfection, and imperfection cannot be meaningful without precision. The echo is that life requires both, inseparably bound. In plain terms, we are alive because the universe is both stable and unstable. If it were only stable, there would be nothing to change. If it were only unstable, there would be nothing to endure. Life thrives in the tension between. This reframing shifts philosophy itself. The question is not whether we are products of design or of chance. The deeper question is whether existence itself requires duality. If so, then meaning emerges not from one answer, but from the collision of opposites. What should that teach us about how to live? Simply put, we cannot untangle fact from reflection. When cosmologists measure light, they uncover story as much as law. When physicists test constants, they reveal fragility as much as necessity. When thinkers invoke multiverses, they gesture to infinity as much as explanation. Our role is to acknowledge the fracture, not erase it. We are mirrors, and our cracks allow us to see more than smoothness ever could. What then is the value of imperfection in ourselves? Are we echoes of the same logic that governs stars? One rhetorical question presses against silence: if flaws sustain life, what flaws sustain meaning? Another follows: if our universe is one among many, does uniqueness matter less or more? And another: if explanation never ends, is pursuit itself the final form of understanding? The questions circle like constellations, visible patterns drawn between distant lights. Each star alone is just a burn, but together they sketch stories. Are those stories illusions, or are they the only way finite minds can embrace the infinite? Why it matters is existential. The scientific search does not merely add knowledge, it redefines our place. We are not outsiders analyzing a machine. We are parts of the process. The laws we study are the same that build our thoughts. The imperfections we find are the same that allow our awareness. This recognition humbles, but also dignifies. We are temporary, but we are also the only voices we know that can name the paradox. If the universe is flawed, then its flaws speak through us. At its core, the echo is that imperfection is not an obstacle to be conquered, but a foundation to be honored. Our sciences are scaffolds. Our philosophies are interpretations. Our lives are enactments of the same paradox. The physicist's equations, the astronomer's maps, the poet's metaphors, all are fragments of the broken mirror. None are whole, but together they reflect something greater. If order bargains with error, then perhaps meaning is the bargain itself. To put it another way, existence is not about perfection. It is about resilience. Stars form, die, and enrich new generations. Life adapts through crisis. Minds question through uncertainty. Every process that endures does so by bending, never by being flawless. What if our pursuit of perfection blinds us to the truth that survival depends on cracks? What if the lesson of the cosmos is that being incomplete is the only way to be whole? In everyday language, think of a song with missing notes. The melody persists because the silence between notes matters as much as the sound. Our universe is such a song. Its silences, its gaps, its imbalances are what make it audible. If it were pure tone, unbroken, it would be nothing but noise. But because it is fractured, it is music. Are we listeners, or are we part of the song itself? One voice echoes across the ages. We live where order and error bargain for time. That line captures the paradox without dissolving it. It reframes human meaning. We do not need to solve the broken mirror. We need to live within it. Meaning is not beyond us. It is in us, shaped by the same flaws that carved galaxies. The stars do not answer our questions, but they remind us that questions are the highest form of participation. The closing image is the sky itself, a vault filled with scars of ancient light, each scar essential. We gaze upward and see not perfection, not randomness, but an intricate pattern of both. The quiet universe hums with imperfection, and in that hum, we find our reflection. The final question hangs unanswered. If life requires both the dial and the wobble, what should we tune? And what should we leave free?